looking at number 20. How does the graph f of x equals 3 times 8 to the x plus 2 compared to the graph of this should be an f of x right here. F of x equals 3 times 8 to the x. So the difference is this plus 2. So if I add something outside, that's going to shift it left or right. So it's positive. So that's going to move it 2 spaces to the right. Okay. 21. Using the table, explain using complete sentences whether it represents a linear or exponential function. So how do you determine? Well, you look at the x's. Okay, so if they increase by 1, then you look at the y values. If these increase by the same amount, like here I'm always adding a 3, that's linear. If this would have jumped by like 2 and then 8 and 16, that's exponential. So if it increases by the same amount or decreases by the same amount, that is a linear. So I would say something like, this is a linear function. Okay, this is a linear function because y increases by the same amount. This is a linear function because y increases by the same amount. Okay. So now they want me to write this in an equation. If you remember to do this, I'm going to have to use point slope form, which I'll kind of write up here as y minus y1 equals m times x minus x1. And you can think of the slope as by how much it increases. Okay, so it goes up by 3. So that's my m. So I'd say y, I'm going to use this first point, the y value is 3 equals 3 times x minus the x value, which is 1. So I use that for right there, I use that for right there, and for my slope I saw that it increased by 3. 22. So there's a lot to this. It looks a little trickier than it does, but it says find the average rate of change for the function over these intervals. Okay? Create a table of values over the interval. So here's the function they're giving me right here. All right. So what we want to do is we want to plug in these values and get answers. So if I plug in a 0, I get 1. If I plug in a 1 on 2, that's a 2. I plug in a 2, that's a 4. I plug in a 3, that's an 8. Plug in a 4, that's a 16. Plug in a 5 right there, that's a 32, and that's a 64. Okay, and so what they're trying to get us to do is kind of look at how things are increasing. So what they're saying is, okay, how does it increase? How much does it increase from, how much does the x increase, or the rate of change from 0 to 2? So from 0 to 2, okay, from 0 to 2, the x values increase by 2. Okay. The x values increase by 2, and the top, okay, increase by 3, from 0 to 2. Okay, sorry, hold on. So, like this. So look and see how much they increase. So we increase from 1, that increased by 3. From 3 over 2, and then from 2 to 4 here, right? The top part increased, the x is increased by 2, and this increased by 12. Okay, and then from 4 to 6 we increase by 2, and the top part, if I do 64 minus 16, that's 48. Okay. All right, so you can see how it's changing. So this thing's not increasing by the same amount. Okay, this is not increasing by the same amount. don't worry about this top question here. We're going to graph this one and come up with an answer. So looking at this, they want us to graph, come up with a solution. So this is a very tricky equation to do. So what I'm going to do is I'm going to take this piece and set it equal to y. And what I'm going to do is I'm going to use a half versus the 0.5. And I'm going to set that one equal to it. Okay. So to do this, let me go ahead and draw myself a little graph here. So looking at this, I'm going to say, okay, I'll graph the first one. Let's graph this one first. Y equals 4. That's a horizontal line. 1, 2, 3, and 4. Okay, it's right there. Okay. So over here, I'm going to plug some values in. Realizing that's a half, that tells me it's going to decrease like this. So I'm assuming it's going to intersect over here somewhere. So I'm going to plug in some negative numbers. I'm going to plug in -1. Let's say y equals half to the -1, and then if you remember we did this earlier, that's going to be 2. So when I'm at -1, I'm at 2. Okay, so when my x is -1, I'm at 2. Okay, and then when let's plug in a -2, y equals 1/2 to the -2, and that equals 1 to the -2, 2 to the -2, and that's going to equal 4. So when I'm at -2, I go to 4. And look at, they're intersecting right there. So this line would continue like this exponential. Okay, so the answer is, what does x equal when they intersect? It's -2. So the answer is x equals -2. Okay. So a family purchases a car for $20,000. The value of the car decreases by 20% each year. After 6 years, the family decides to sell the car. Should they sell the car? So they sell it for $4,000. Explain your reasoning. So here's the main thing you got to remember. The rate here for decreases, okay, is 1 minus this for decay. Okay, so the rate I'm going to use is it's going to be 0.8. 0.8. So this would be y equals 20,000 times the rate of decay, which is 0.8. And they want to say after 6 years. So that would be the equation right there that I'm going to write. That's what I started with. That's the rate of decay. Well, they want to know what's it worth after 6 years. So I'm going to figure that out to the 6th. Going to my calculator, I'm going to say, okay, 0.8 to the 6th